the question is, basically every question starts with how many ways? Right? All right. How many ways, blah, blah, blah. We're going to fill in the blah, 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 right? And there's going to be two things that, there's going to be two conditions that we're going to be dealing with. One condition is, all right, we're going to talk about when you're allowed, and actually the way we're counting today, everything we're counting today, order matters. All right? So everything we do today, order matters, right? There's two things that can happen. One is we can repeat and not repeat, okay? Really boring, right? So you can repeat or not repeat. So those are, so like day one is how many ways an order matters, and then we can repeat and we can not repeat, and we're going to talk about different, how do you approach each of these situations. The next lesson, which for you guys will be Wednesday, for everybody else will be the next lesson, we'll have the next lesson. We're going to talk about how do you count when order doesn't matter, right? So today is all about when order matters. And it's got a special name, and I'll talk about the special name, and you'll say, oh yeah, I may have heard that before, and it doesn't matter if you heard it or not. All that really matters is order. Order matters, right? That's it. If you see order matters, or if it's implied in the problem that order matters, this is how we count the ways. Got it? So, let's see. How many ways? How about phone numbers? Okay. How many digits are in a phone number? that answer's different when I first started teaching. Actually, when I first started, well, actually it had happened after I started teaching. But believe it or not, if you were in the city of Atlanta years and years ago, I'm just curious, does anybody still have a phone, a physical phone, a landline? Does it work? Whoa. Okay, so you still have a landline you call. Does anyone have a rotary phone? Does anyone know what a rotary phone is? It's got the little thing and it goes, you hated any numbers that had 9 because it took forever. So believe it or not, up until the early 90s, if you were in the city of Atlanta, if you just wanted to, like my home phone number was 2336303. You only had to dial 7 digits. It was when people started getting cell phones that you said, well, wait, we need more numbers, and so now you had to put the area code. And for years, the area code for the north half of Georgia was 404. That was it. Then it was 404 was the Atlanta area, then it was 706 was outside of Atlanta, and then in the early 90s they called it the donut. It was 770. So you had Atlanta, which was 404, and then literally it looked like a donut. Everything out here was 770, and then everything outside of that was 706. Right? Of course, with more cell phones, now you have 678. And isn't there another one now?
470.
470, yeah. So they've had to keep warning us. But let's let's count number of phone numbers. Let's sort of count the number of phone numbers for, I guess, total, right? So we have our 7 digits. And here's the big deal. When order matters, draw dashes. So the original 7-digit phone number had 1, 2, 3, 1, 2, 3, 4, right? And you had the area code, which is 1, 2, 3. Right? So if you're counting total number of phone numbers, right, what you do is you count, well, how many different options do I have for this spot? 9? 10? So I think you only have 9 spots for this, because you can use the numbers 1 through 9. I don't think you can start with a 0. Right? You have issues starting with a 0, don't you? Because if you start with a 0, you dial the operator. Does everybody understand that part? And also, you have issues starting with a 1. And you don't know this because you don't know what long distance is. But years and years and years ago, right, you used to have to pay to call. If you were here, like I was at school in Athens, right? If I wanted to call my parents or my parents wanted to call me, they had to pay extra to call from here to here. At which point you go, that is absolutely ridiculous, right? Because you can call across the country and it doesn't matter, right? But years and years, I guess you have to think about it, you're calling a different country, then they charge per minute. But not 20 years ago, to call from here to here, you paid per minute. And the way you identified that you were dialing long distance is you said 1. And so if you type a 1, you're telling the phone company you're about to use long distance and they're going to charge you. Or if you put a 0, you're telling the phone company I need to call the operator. Of course, nobody ever calls the operator anymore, but this is an old problem. So normally you'd like to think that you could use the digits 0 through 9, which would be 10 digits, but you can't start with a 0 or 1. So this only has 8, right? But this one, how many options do we have for this spot? 10. How many options do we have for this one? 10, right? Okay, now, your regular 7-digit phone number still had those rules because years ago, you only had to dial 7 digits to call somebody, right? So you couldn't have, this couldn't be a 0 or 1, so how many options do you have for this? 8. And 10, 10, 10, 10, 10, no restrictions everywhere else. And so if you want to know how many phone numbers you could possibly have, you multiply this times 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 this, right? And you get a pretty big number. And that's basically how many different phone numbers you could have. Everybody understand how we just counted the ways? Like, I want to know how many phone numbers can you have? Well, this is how many distinct phone numbers you could have. Now, let's answer the question. Were we allowed to repeat things? Are you allowed to have the same number repeat in your phone number? Yeah. So notice things could repeat, so this goes here, all right? And so your answer here, you type in your calculator, and it ends up being, I think 64 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, times 10 to the 8th. That's a big number, right? All right, next. All right, are we okay with this part? Does everybody see what happens when things can repeat? All right, now let's talk about, and I'm going to use the word. I'm going to use the word "word" for a minute, because I'm going to ask how many words, and I need to. These aren't real words. We're not asking how many words. Like when I say how many words and give like this next situation, it's not like you can look it up in the dictionary, right? We're just going to call any kind of word is a collection of letters that's in a certain order. All right? Got it? So how many words? How many words contain 2 letters? And here's how you think about it. Well, if it's got 2 letters, we got position 1, position 2. Everybody okay with that? And you think, how many options do you have for the first position? 26. How many options do you have for the second position? You can repeat. 26. Oh, can letters repeat in a word? Yeah.
But if it's 2 letters, but if they were both A's, it'll only be 1 letter, right?
But AA is different than AB, isn't it?
Right.
Or AA is different than BB or whatever, right? So if you are, when order matters, and in a word, order matters, right? Because you don't just, words are always spelled in a line. They're never really spelled in a circle where it doesn't matter, right? A word, the order in which the letters are written matters, right? So if I talk about words and I say, well, just 2 letters, it's going to be 26 times 26. So I get 26 times 26, which is 576. And obviously use a calculator. I'm not expecting anyone to know what this is off the top of their head.
Did you know that on the computer?
Well, yeah.
How do you know that?
Because I know my perfect squares up to that far.
That's crazy.
Okay. So are we okay with this? So whenever order matters, the takeaway from this is draw dashes. right? Yeah, there's a formula I'm going to talk about, and you can look at the formula. But whenever order matters, I want you to draw dashes, and under the dash, I want you to think, how many options do you have for the first dash? How many options do you have for the second dash? All right? Okay, back to this how many words business. How many words can we make from the letters A, B, C, D, E? Actually, how many 5-letter words from here, right? And we're going to have the rules, all right? You're not allowed to repeat, so non-repeating letters. And I think this is where y'all are thinking. So if I want a 5-letter word, so 1, 2, 3, 4, 5, and here's how I want you to think about it. Imagine that I have 5 ping pong balls. Everybody imagine 5 ping pong balls? And on one of the ping pong balls, I have the letter A, B, C, D. You got it? So I have 5 ping pong balls with the letters A, B, C, D on them. And so if I want to count how many 5-letter words where I'm not allowed to repeat, where letters can't repeat, you sort of randomly pick, right? So in that bag of ping pong balls, when I go down to pick the first ping pong balls, how many options do I have? 5. I have 5. Okay. All right, now I pick that ping pong ball up and put it up here, right? Now I'm going to go back in the bag and pull the ping pong ball out. How many options do I have for the second letter? 4. How many options do I have for the third? 3. How many of the last? 2. Does everybody see how we got that? Does the visualization, do y'all see the visualization? It's like, it's how many options, how many ping pong balls are in the bag, right? And that's how many choices you have, right? So at first I have 5, and then I only have 4, 3, 2, 1. Of course, when you multiply all those together, you get, what's that, 520? No, 120. All right, now, believe it or not, this idea of multiplying 5, 4, 3, 2, 1 is going to show up a lot over the next couple of lessons. All right? And it shows up frequently enough, it kind of gets its own math symbol, right? And so I want to talk about this math symbol. It's an exclamation point, right? Now, in math class, if you ever see an exclamation point, this does not mean 5! Had to be a little louder to get through the mask, okay? Thanks for laughing. Sorry for scaring you. Okay. All right. When you see an exclamation point in a math link, this is actually called factorial. All right? And this is read 5 factorial. All right? And what 5 factorial means is it means 5 times 4 times 3 times 2 times 1. All right? Which we already found out is 120, right? And, let's think of some other numbers. If I wanted 6 factorial, guess what that's going to be? Well, no. 6 times 5 times 4 times 3. Is everybody okay with that? So this is 6 times 5 times 4 times 3 times 2 times 1, right? It gets a little more interesting when you deal with smaller numbers. What is 1 factorial? Well, think about what 1 factorial is, right? Well, 1 factorial is just going to be 1 times 1, right? Which just gives us 1. And then there's this thing, 0 factorial. So what would you think 0 factorial would be? If I were in high school, I would think 0. But it's not. I actually saw, I haven't clicked on the video, and I probably should, that somebody that's really smart that is explaining why 0 factorial is what I'm about to tell you. But what I always tell my students is I'm about to introduce some formulas that use the factorial symbol. And pretty much in math you get to define certain things, and they've actually defined 0 factorial is equal to 1. And the reason they define 0 factorial to be 1, I think, is it makes the formulas work out nice. Right? There is probably a clever explanation that I probably should have clicked on that video just where he told me why 0 factorial equal to 1. But basically my explanation for this has always been, well, we need it to equal 1 so other stuff works out. So, does this make sense? All right, so here, let's do some computation with factorials because I think it's fun. Okay, so I want to do something weird like 7 factorial over 5 factorial. Right? Yes, your calculator does it, right? You don't need a calculator for this. I'll guarantee that you don't need a calculator for this. So what does 7 factorial mean? Okay, so that means 7 times 6 times 5 times 4 times 3 times 2 times 1. What does 5 factorial mean? 5 times 4 times 3 times 2 times 1. What do you notice is going to cancel? So what's left? 7 times 6, which is 42. See, I told you you could do this without a calculator. Does that make sense? And so when you have to compute, like computing stuff with factorials, there are some tricky questions. Don't worry, Alex doesn't have any of them. I do want to show you some of the tricky questions that involve factorial. Like, for example, what if I gave you x plus 1 factorial over x minus 1 factorial? Like, how would you simplify this? Well, your calculator ain't going to do that, right? Okay. So, but are we okay that factorial is that number times 1 less than that, times 1 less than that, times 1 less than that, times 1 less than that? So can we look at x plus 1 factorial as the same thing as x plus 1 times 1 less than that is x, times 1 less than that is x minus 1, times 1 less than that is x minus 2, times a whole bunch of stuff that's smaller? And then can we think of x minus 1 factorial as x minus 1 times x minus 2 times x minus 3 times a bunch of stuff? Because it's like you could keep multiplying times a number less. And what do you notice is going to happen here? A bunch of stuff cancels out, right? Because this cancels that. Does that make sense? And so my final answer for this is just x times x plus 1. Yeah, I'll just leave it that way. I mean, you could distribute it, but I don't care. Now, the good news is I'm not going to ask anything super tricky with factorials. For you to do factorial, for you to be able to do it, it has to be a positive integer. Like, you don't know. There are some tricks for factorial of a negative number, but that's nowhere close to this course. There are some tricks when you have factorials of fraction numbers. That's nowhere close to this course. There's some weird ways to do that. But you're responsible for what's 3 factorial, what's 6 factorial, what's 7 factorial. Got it? All right? So are we okay with factorial? All right? Don't worry, I'm not going to yell at you again. I actually feel bad. I didn't expect you to jump that much. You guys laughed, but no. All right, so why did I talk about 5 factorial? Well, let's go back to my original question, right? How many words so actually how many, I'll leave a blank in that. I still have the letters A, B, C, D, E, but now I want to know how many 3-letter words. The question is, how many three-letter words can I get from here? And here, no repeating. So how many three-letter words can I get from these 5 letters if I'm not allowed to repeat? Well, right when I see three-letter words, I go, well, I know how to handle this. I'm going to put my 3 dashes. And so I think, well, how many options do you have for the first letter, first spot? 5. How many options do you have for the second spot? 4. How many options do you have for the third spot? 3. And so then I do this times this times this, and oh. So that means I can get 60 three-letter words where no letter's allowed to repeat. Everybody see that? Now, just curious, right? If I were trying to use factorial notation, I couldn't just say, do you see that I couldn't just say 5 factorial? Because 5 factorial is too big, isn't it? We already found that was 120. Mathematically, what I'm doing is, there's actually a formula, and I'm going to talk about that formula very shortly after I do this. So the mathematical formula is 5 factorial over this formula gives me this answer. And let's talk about where the 5 and the 8, so I just made this formula up. I'm crazy. But let's see how I came up with this formula. Does everybody understand where the 5 comes from? What did 5 come from? The number of choices, right? Where did the 3 come from? Number of positions. Are we okay with that? So everybody see that the 5 comes from your total number of choices, and the 3 comes from our positions, right? Now, if I were to work this out, this would be 5 factorial over 2 factorial, right? And if you were to write this out, that's 5 times 4 times 3 times 2 times 1 over 2 times 1. Oh, look, that gives me the 5 times 4 times 3. Does everybody see that this gives me this? So far, so good. All right, this has a special name. This is called, and this is kind of the whole idea of today, this is called a permutation. And just curious, have y'all heard of the word permutation before? I didn't ask if you understood it. Okay, yeah. Well, right when I put that down, oh yeah, I've heard permutation. Okay. Permutation in a math class, have y'all heard of permutation in a math class? It's usually, they're paired with something called permutation, something called a combination. Have y'all heard of permutations and combinations before? You have? But I think you had a crazy math teacher too, so you may have learned some stuff there. Do you need to know the word permutation? No. Right? You don't need to know the word permutation. Here's what you need to know. Order matters. Can everybody understand that? And anytime you hear order matters, you draw your dashes. And you start thinking, what are my choices? Right? Technically, it's called a permutation. Now, there is some notation for this. And your calculator has this. So if you have your calculator out, you get your graphing calculator, I know has it. Most scientific calculators have it. Right? So the official title for this is, this would be the permutation of 5 things taken 3 at a time. This is the official title for it, where you have 5 things and you have 3 spots. I always have trouble remembering this until I remember, okay, this number's always got to be smaller than this one. So how do you type this in? Well, oh shoot, I don't have my calculator up and running. I'm going to try. Everybody hit math if you've got your calculator. There's usually something where it says in, well, that's an awful one, even by my standards. there's NPR. So if you hit math, I think if we turn it on and you hit math and you go PROB. So I don't know if you can see this. So you hit math and then you go all the way to PRB. Does everybody see the NPR at the top? Now this is kind of tricky because if you just hit NPR now, you're going to get an error. Okay? The reason you're going to hit an arrow is if I want to type in 5P3, I have to put the 5 first. So hit clear, right? Hit the 5. Make sure you have a 5. And then hit math. Scroll over to the probability. And then our first one is NPR. And when you press enter, notice how it kind of creates that little symbol where there's like a subscript here. And then if I hit a 3, yay, there it is. And I do all this work and yay, it tells me 60. Does that make sense? Well, why am I telling you how to use this notation is, well, the homework that I'm going to give you that you will do tomorrow has this. And so I need to make sure you know how to type it in your calculator. You should have it in there. There's a PRB here. This does have it. Probability.
Oh. Wait, but then.
But you got to put the 5 first. So here, let's clear. So let's put the 5, PRB.
Yeah, mine worked when I just put it in.
Yes, Ross.
Yeah.
Mine just worked where I just put it in.
Oh, yeah, okay. They updated the system a while ago. But before they've updated it, of course they probably updated it 10 years ago, but okay. The way it used to be, you had to, but all right. Is everybody okay typing this in? Technically you can compute it by hand, but doesn't matter. All right. So are we okay with this kind of counting? So it's how many words and there's no repeating. And so now I have to do one more problem. Right? And, well, actually, 2 more problems. One exactly like what we did, right? So, who runs track? How many lanes are there on the field, on the track?
8.
There are 8. Oh, good. I wanted 8, right? So 8 people can run, right? Sometimes, well, no, we're going to say full track, okay? All right, so we got 8 people running, all right? So we have 8 people running, right? And I'm assuming they still have, you get a prize for first, second, and third, right? So if 8 people are running, I want to know how many different ways can we have a first, second, and third place? Okay? And so how you think about it. First, second, and third place, right? How many people can come in first? 8. All right, that person's across the line. How many people can come in second? That person's across the line. How many people can come in third? 6. 6 times 7 times 6. Does that make sense? Officially, and honestly, this is how I want you to do the problem. I want you to draw dashes. I want you to say 8 times 7 times 6. Get your answer. That's what I want. I mean, some teachers may say, no, this is 8. The permutation of 8 things taken 3 at a time. That's the official notation for this. But honestly, anytime you do permutations, I would rather see you draw dashes and say how many options you have for each of those parts. Because your ability to remember this on the SAT, I think, is pretty slim. But your ability to remember, I'm just going to draw dashes and find out how many ways each of these can happen, I think you got a better chance of doing that than remembering this. Are we okay? So I said 2 more problems. That was the first. Now here's the second problem. And I call this the banana problem. because the first year I taught this, the example they gave used the word banana. Actually, I lied. We're going to do an intro alert. Here, don't write this down. We're going to do this, all right? How many four-letter words can I make? How many different four-letter words? If I'm only allowed to use, I can't repeat it. Imagine that these four letters are on ping pong balls and I need to make four-letter words. Right? So how many different words can I make from the letters in math? So how many options do you have for this? 4, 3, 2, 1. You multiply together. And so I can get 24. Everybody okay with that? Why is this? So it's the same thing. How many different 6-letter words can I make from banana? Do I understand that that's a little harder? And the reason it's a little harder, right? I mean, if you just try to put your 6 letters down, 1, 2, 3, 4, 5, 6, you can't just say this is 6 times 5 times 4 times 3 times 2 times 1, right? You can't just say 6 factorial because letters repeat, don't they? Like, for example, if I want distinct words, and let's just look at the ends. Let's say I've got a green end and I've got a blue end. I could have a green end and a blue end, and I could have a blue end and a green end, and they would be the exact same word, wouldn't they? Does that part make sense? And so how do you solve the banana problem? Well, first, if the letters don't repeat, the answer is pretty easy. There's 4 letters, you just do 4 factorial, and you're done. That's where we got the 24. If the letters repeat, can we agree that 6 factorial is too big? Because there's going to be some, 6 factorial gives me all the different combinations of this, but some of those combinations look exactly the same. So we've got to take some of them away. And here's how you take them away. We're going to divide, and how many b's do we have? 1. So I'm going to divide by 1 factorial. How many a's do we have? 3. So I'm going to divide by 3 factorial. How many n's do we have? 2. So I'll divide by 2 factorial. And there's a complicated explanation, and every year I try it, and it was just messing the whole thing up. And usually I just say, okay, I call it the banana problem. So anytime, and you will be asked, anytime you have, they say, you know, like how many different 4-letter words can you make of math? If the letters don't repeat, you just get to say 4 factorial. Right? If the letters repeat, you have to divide out by how many they repeat by the factorial part. All right? So here is